Welcome everyone to the code structure auto-grading webinar using Semgrep. And I know a lot of you have already been using Semgrep. I have been mentioning Semgrep for about a year now in different webinars that I've been doing and also in some of our blog posts. It's a very powerful tool, and even though some of you are already using it, I think it's good to share some more basics for your understanding of Semgrep, and maybe if you're not using it, show you how you can start using it. It's very easy and it's very effective, and with the wrapper that we created for it, it's also very useful for educational purposes. So let's get started. Today, first of all, I want to share some more thoughts on why code structure is important to autograde, or why you would even want to start autograding that. Then I'll go over what is Semgrep, how did I get by Semgrep, and share Semgrep basics with you, just so you have an understanding of how you can use the tool and you can get creative with it for your own assignments. Then finally, to make it all a little bit more concrete, we'll go over some very easy but common examples of using Semgrep. We'll be creating the configuration files together, setting them up inside CodeGrade, and I'll show you step by step how you can do that. Right. Great. So let's start with why autograding code structure and what to grade. So of course, when autograding your assignments, probably what you're doing now is you have IO tests or unit tests that will autograde the code functionality within CodeGrade, and you will maybe use a code quality test and or linter to autograde the code style. However, when it comes to the code structure, then you will probably do it manually. For instance, if you want to check if students use the correct methods, if they did not hard code any answers, if they do not make any common mistakes or misconceptions or any other possible edge cases, most teachers go through the files and do these manually. Last year, around this time, I had many instructors actually requesting me, how can I do these things automatically as well? And my answer most of the times was a little bit complicated. And I would say, well, we could write a custom script, maybe with Python, to get the abstract syntax tree. And then from there, we can kind of parse the structure of the code and see if they do the right things. But after researching a couple of options, I came about Semgrep, and I was super enthusiastic about it because it does do exactly what you need for all of these use cases. So what I saw is that many of the graders that I was talking to, next to the auto grading of the IO tests or like the functionality and the code quality, they had a list of things that they wanted to check. Either they had this physically and they shared it among each other, or they had a mental list at least. They would go through the code and let's say in file X, they would click on file X and check if in this specific function or method, the student did not forget whether the output is null, or they check in another file if the student does not use any prohibited external libraries, or they will see if the student used recursion and not a loop, because recursion was the objective of the assignment. And of course, with CodeGrade already, going through the files and giving inline comments on these things is already a little bit efficient. But it would be way better to automate this, since you already know exactly in which file you have to look, and you're just repeating this task. So of course, we want to automate all these repetitive tasks. So that is where CodeGrade and Semgrep come into play. So when we automate this, of course, there's a lot of benefits, and the ones for the graders are obvious. As always, it saves time on repetitive checks. There's more time to check real rarities and edge cases in students' code that you are not on your mental list already, and more time to give actual custom feedback using the inline comments. Also for students, it's really useful because what is nice is with the instant feedback, they'll instantly see if they made structural errors before the deadline, so they can fix these things before the deadline and actually learn from them. Also, it prevents students from thinking that they solved the assignment without actually meeting the learning objectives that you've set up. For instance, they used a simple loop instead of using recursion, which is very frustrating for both the teacher and the student, and it happens quite often that these situations occur. So there's a lot of benefits for the student as well. So let's talk about what Semgrep is and how you can set it up with CodeGrade. So Semgrep It's a tool. It's short for semantic grep. It's basically grep as you know it, but it is semantic. So instead of grepping a literal match, you can make it a little bit more precise when it comes to checking the code structure. It's a static code analysis tool to check for structures. It's an open source tool that was developed by R2C, which started off as a research group within Facebook and now is their own company when it comes to security. It is easily installed in the command line interface as a command line interface tool through Homebrew if you're using macOS, or pip if you use another system and you have Python installed. It's originally developed as a security tool to find bugs in code and enforce code standards, and also find common misconceptions and errors. Of course, within CodeGrade, we use it a little bit different, but it is a tool that is very useful for that as well. So the nice thing about Semgrep is that just like CodeGrade, they strive to be language agnostic, and they're doing a good job on that, because last year when I found out about Semgrep, they did not offer that many languages yet. But now, a year later, development has gone really fast, and they're already supporting way more languages than last year. Popular languages that probably a lot of you will teach, like Python, Java, JavaScript, C#, they are all generally available in Semgrep. They're tested and they are ready to use. But some other languages like Kotlin, that's becoming more popular as well, C, C++, those are all in the beta or experimental phase. You can use them already, but Semgrep says that they're not fully tested yet. But judging by how fast the development has gone over the past year, I think it's not long before they are generally available as well. So this is a very hip slide that I thought I'd put in because, of course, we're a hip and young company. It's why Semgrep and CodeGrade is such a good combination. CodeGrade, we have created a wrapper script around Semgrep that makes it more useful for educational purposes. Also, we have added this wrapper script readily available inside Autotest, so it can be used in the unit test step without any prior setup for you. You simply upload your rules and patterns to CodeGrade and Semgrep, and CodeGrade will do the rest, and the output will be very useful for the student. So what we've added in this wrapper script makes it more educational than the regular Semgrep version, is that with the regular Semgrep, you can only do a negative match. So that means that you can look for unwanted patterns, which is also what they started it off with, looking for errors or vulnerabilities inside code, which is just negative matches. In other words, this is a part of code that should not be there. However, when you're using it in, let's say, your Python introductory course, you may also want to look for wished for patterns. Let's say you have a simple assignment where a student has to use a for loop and not a while loop. You can look for a for loop, and it shouldn't error if the student has a for loop. So you want that match to be there. And that's what we call a positive match with CodeGrade. And we'll get to the configuration file later, but basically, concretely what we've added another field in the configuration file that CodeGrade will read, which is the match expected field. Can be either true or false, depending on whether you want a negative match, so looking for unwanted patterns, or you want a positive match, looking for wanted structure. So that's what CodeGrade does. So talking about these patterns, let's head on and tell you a little bit more about what they look like and what you can do with them. But before I do that, Sam, are there any questions?
No, at this moment, there aren't any questions, but Chris Levy did mention that they do not support SQL at the moment, but hopefully they will soon, because that would be really great. Yeah. So from my experience last year, they just supported around 10 languages, and this list is now already way bigger. So it wouldn't surprise me if they do offer SQL soon as well. Great. So let's get started with the patterns then, which is really the heart of a Semgrep configuration file. And patterns, well, as the name suggests, they allow you to match what you are looking for. But Semgrep offers you a lot of things within these patterns that make it, well, semantic, which is what they promise as well, and that allow you to be more flexible when looking for code. So a full list, and they have very good documentation themselves, a full list of all the patterns
The edge cases and also the language specific use cases of these patterns can be found on our website, which is semgrep.dev. I'll just cover the basics right now that I found to be well, useful enough to really cover a full introductory Python course, and maybe even a little bit further than that. But just know that there's a lot more possible, and you can find all of that on Semgrep. All right. So the 4 different types of patterns that I'll be talking about today are pattern matching, equivalences, ellipses, and the meta variables. I'll start with pattern matching, which is the easiest one, which is also something that other tools can probably do, which is just traditional pattern matchings, looking for literal matches. So let's say we want to check if the student somewhere in their code does a return 42, and it will just look through the code and it will find it, in this case, twice within the function here, within the nested if and within the function right here. So very straightforward, just literal pattern matching. Then next to that, Semgrep will automatically look for code that is semantically equivalent to your pattern. And that's one of the things that makes it so powerful, because it will give you that flexibility. So let's say right here, we're looking for a pattern which says set password. So the student will use this function and they will give the literal string password in. And in this case, it will yield, well, it says 2 here. It should say 1, but it will yield a response here, even though literally the student has not said set password with password, the string password in here as an argument, but instead they hard-coded the password up here and they pass in this variable. So even though literally it's not the same, Semgrep will still give a match, in this case, this match right here, the last line, because it is semantically equivalent to your pattern. And that is what makes Semgrep so powerful. What's nice also, next to that, Semgrep will look at the FQN, the fully qualified name, when you're dealing with functions from other modules. So in this case, for instance, in Java, if you use system.out.println, you can also put a reference to println in your Semgrep pattern, and both will go for the same fully qualified name. So that just makes it a little bit more powerful when students are, for instance, just in Python, for instance, you can just import a couple of functions from a module, and if they do that, it will still look for the FQN. So that's good to know. That makes it very powerful. Next to that, and now we're getting to the actual syntax of the patterns, is the ellipsis operator. And if you're used to regex, this is kind of like a wildcard or a star in regex. But in Semgrep, it is 3 dots, so the ellipsis. And this can abstract away 0 or more arguments, statements, parameters, lines of code, fields, characters, etc. All of that. So a good example down here is where we use the request.get function. And what we want to do here is we want to make sure that it has at least the verify is equals false argument or parameter right here. And it can have an argument in front and it can have an argument afterwards. But both of these, as it is an ellipsis, so it can have 0 or more matches. In this case, it will match all of these lines below. So if there's nothing before it, it will match it. If there's both one before and after it, it will match. And if there's nothing after it, it will also match. So that is a very powerful operator that I'll definitely use in the examples later on as well. Next to the ellipses, there's another operator that you can use, and that is the meta variable operator. A very basic example of what the difference is between, let's say, an ellipsis and a meta variable, and what makes a meta variable more powerful in some cases is that a meta variable keeps its its value, so you can reuse them. So in this case, if we want to look within the code for useless assignments, in this case right here, we can look for meta variable x equals a random meta variable y, and then we can see meta variable x equals meta variable c. In this case, the first line is useless, of course, since we're reassigning right after that. And because these meta variables keep their value, in this case, these will have the same value. We can reuse them and we can check if there's actually a useless statement. In this case, there's a useless assignment right here, and this will be parsed, since in this case, initial value is X and X. A meta variable is always starts with a $, and then it uses capital letters, it uses numbers, and a lower underscore. All right, and that is, oh, there we go. I missed this slide. So that's what I was saying. Always start with a $, contain uppercase characters, underscores, and digits. It can be compared with the capture groups in regex. And if you're using a type language like Java, C, TypeScript, Go, you can also have a type meta variable, making it even more effective. So you can say that it is a variable that has to be the type string or integer, things like that. So another thing that Semgrep offers, and I think is very powerful, is the playground. So this is an environment on the Semgrep website where you can try out your patterns. You can, I'll go there. All right. So what's nice about this is that you can just copy and paste the test code in here. So that could be the student code or your example solution. And then you can try out your patterns right here. If you click on the advanced tab right here, you'll find the whole configuration. And all these fields I'll discuss in a little bit. But right here, we can actually try out our configuration. So for instance, here, when we're looking for a simple assignment, so we just say meta variable X becomes meta variable Y, and we run this, we'll see that we get 2 matches, both the first line and the second line. But now, let's say we want to check if it is password. We will only get the second line because the first line will have is a different assignment. So some common pitfalls with these patterns. The first one is the meta variables versus ellipses. At first, they might seem very similar, but there is a subtle difference, which is that meta variables must always match an expression, and an ellipsis can match 0 or more expressions. So that's what we've seen also before with this ellipsis example. It didn't need to match one of those parameters. Next to that, your patterns must be complete and parsable in the programming language. So if you want to parse incomplete lines of code, you can do that, but you will have to use something like ellipsis to make it a complete part that is parsable in the programming language you choose. Finally, and that is important as well, is that if you use the playground and you go to the advanced tab and you copy over this configuration right here, it is a valid Semgrep configuration, of course, but since the CodeGrade wrapper has added the match expected field to this, this will not be a valid CodeGrade configuration file. And there has to be one field added here, which is the match expected. Great. So now that we've been there, let's go to the rules right away, to the rule syntax. We've already had a sneak preview of that. So rules, as we see right here, are just very simple files. Actually, they are YAML files, which are files with the extension .yml or .yaml, and they have some required and some optional fields per rule. And one of these configuration files can have multiple rules in sequence. As you can see right here, we can, in this case, we have one rule, but I can simply copy and paste this over down here, and I can add a rule, which will still be a valid configuration file. Oh yeah, note to self, very good. I'm not going to forget about my fun fact. A fun fact about this fun fact, every Friday we do a fun fact at the office. And I skipped mine today because I was going to do it in the webinar. So here it is. YAML actually stands for yet another markup language, which is, of course, the yet another prefix was very popular back in the day. However, they kind of found out that they're not really a markup language, but they're more of a document structure language. So they changed the acronym to Jekyll ain't a markup language. So now Jekyll is a recursive acronym, which is also very popular, of course, in computer science. Another fun fact about this is if you look at the official documentation of JAML, they always like to add the JAML rhymes with camel part behind their name. So I found it pretty interesting. Maybe you guys find it interesting too. All right, so sorry about that small intermezzo. Right here, we have a very simple rule syntax, as we've seen in the playground as well. However, we have the match expected field added right here. So this is a very simple one, a Python one, where we check if the student used the for loop or not. As you can see, I'm not having a impartial code right here. It's still parsable because even though I am just looking for a for loop without actually caring what's in it, I'm using the ellipses right here to parse any number of lines that are in there. So in these rules, there are a couple of required fields. The first one is the ID. And the ID is shown inside CodeGrade's unit step as well as the name of that individual rule. The message, which is also shown in CodeGrade's unit step, and which is a great place to explain why this rule is there and what you're actually checking. The severity level, which is at this moment not used within CodeGrade, but in the future we may use it to add weight to these different types of rules. Language is very important. This is the programming language that you use in this case. A full list of the programming languages is on Semgrep's documentation. And finally, the pattern, which is the pattern itself. But instead of pattern, you can also select patterns or pattern either or pattern regex. So if you want to use a regex, you can use that. Pattern either is a conditional or, so it has to be matching any of the patterns that you type underneath that. Patterns is if you want to have multiple patterns that it has to match. And then pattern if you just have one pattern, of course. Then, of course, the required field that is added by CodeGrade is the match expected field, which can be true or false. There are also a lot of different rules that you can use within the patterns field, and they are right here. I'll not cover them today, but just know that they are there and that you can use them. So, for instance, the pattern not or the pattern not regex can be very useful as well. Now, for the rule syntax example, this is the rule, and we can see that the ID in this case is for loop, and the message here is did you use a for loop in your script, and the pattern is right here. So those are the most important parts of this. And now to what this looks like inside CodeGrade. So as I mentioned, Semgrep is built into CodeGrade's unit test step, including our wrapper script. Your YAML configuration file is uploaded as a fixture, and all the individual rules will show up in the unit test, just like you're expected it to, just like it would with your JUnit or PyTest as well. Each individual rule will have its own individual step within the unit test automatically. So in CodeGrade, what it will look like, so we have this rule again with the ID and the message. As you can see, the Semgrep tests will show a list of all the rules. In this case, we just have one rule. If you have multiple, there will be multiple right here. The ID will be shown in red or pink in front of the message that is written right here. So yeah, very straightforward. This is set up within CodeGrade. As I said, a unit test step, you select the unit test framework Semgrep, and then as extra argument, what you can do is you can give up the YML file that you have uploaded. In this case, it's in the fixtures folder, and then you just select the student file that you want to check for the structure in. This can be a individual file like I'm doing right here, but you can also give a full folder. So if you do not care what the name of the file is, for instance, or you want to check over all the files that the student has added in, you can just select the student folder and it will look through all the files for the structure. In this case, I'm looking for a specific structure in the specific file called factorial.py, which the student has uploaded. Great. So now we've covered the basics. Let's go ahead and set up some real-world examples, starting with one in Python, where we're going to check for import statements. So in this case, a very common example is prohibiting students to use a specific library. maybe because it will already solve the problem for them, and thus they will not meet the learning objective. But it's also possible that you give your students a little bit more freedom, and this specific library is very common that the students use it, but you do not want it to be installed in the auto test environment, and you want to make your students aware of that proactively. And with Semgrep, it's really nice that you can give these proactive, helpful messages to your student by having this test before it and just checking if they use this specific library. And if they do use it and it doesn't work, you can tell them this library is not installed, try another library. Also, there's the option, of course, that we want the students to use a specific library because it is part of the learning goals. For instance, pandas for data science. In our case, however, what we want to do now is that we do not allow our students to import Python's pandas library. So we're going to create a Semgrep configuration file where the student is not allowed to use pandas. Great. So let's get started. And I have to change my screen right here. Great. Are you able to see my screen right here? Yes.
Yes, we are.
Great. So I have the rule right here. We're going to recreate this just so you can see exactly what goes in this. All right. So let's save this file first as a YML file. In this case, it is example1, and I want this to be called import.yml. So we always start with rules. Just going to be the list of rules, and then at first we're going to give the ID of this rule. So you can see right here. Should indent here. And the ID can be any name that you're going to give to this file. In this case, or to this rule, as I said, it will show up in the unit test as well. So in this case, I'll call it pandas import. After that, I always like to start off with the match expected field, which in this case is false. We're not expecting a match because we do not want the students to have this structure within their code. And the actual pattern will, of course, be import pandas. Perfect. Very easy. This is one of those literal pattern matches as before. So next to that, we have the message, severity, and the language. So let me add the message. And the message in this case is you. All right. The severity is info. Again, doesn't matter. It's not used yet, but maybe used in future. And then the language, of course, language is Python. And of course, if you're doing this in Java, this will say Java. Bear in mind that, again, these patterns have to be parsable within the language that you're using. So, of course, the syntax of importing something within Java or any other language that you're using could be different from the syntax in Python. So you do need to change your patterns as well to the language that you're using. In this case, we're using Python, and import pandas is valid Python. Great. So I save this, and now I have to change my screen back to the browser. Great. And I have the first example right here. Let me just check if I already uploaded. No, let me quickly upload the example right here. So I've uploaded a simple file to this, and maybe you'll see here why we're not allowed to use pandas. In this case, of course, all we're doing is printing something, so pandas is not used for this. So let's set up our test. Manage assignment. And again, of course, first step is always to create a quick rubric. I'll create a quick rubric. And I'll say 0 points used, 100 points. You see, there's a very easy assignment to pass. All you have to do is not use pandas. So let's set up this auto test. First step is, of course, uploading the configuration file that I just created. So let me do that. Submit it as a fixture. And now we can already start creating our unit test. So we're going to the unit test step. First, of course, select the rubric. And then let's just call this unit testing framework. We select Semgrep. And as extra argument, again, first we select our configuration file, which in this case is called import.yml, which is in the fixtures directory. And let's just say that we look for this structure in any file that the student has uploaded. We don't care what the name of the file is. We just look for any import of pandas because we don't want that. So let me start this up and hope I didn't make any typos. And in a couple seconds, we'll see that. This would be a great time for questions, by the way, but I don't think there are any, right? All right. Well, building the VM now, and let's just hope that we didn't make any typos.
Devin, I have a question for you.
Yes.
Is it pronounced YAML or JAML?
That's a good question. Well, it has to rhyme with camel, so it is actually pronounced JAML. Well, makes sense why they added it now. Thanks for the question. And in the meantime, this passed, so we didn't make any typos. That's great. We're not using pandas in this assignment. Let me quickly upload a file where I am using pandas, so you can see that that will crash or error and give a helpful message saying you're not allowed to use pandas. So you can see why this can be useful for your own class. Let's say you want your students to use pandas, or maybe you don't want them to use the library like TensorFlow, but you want them to do some of their own stuff. There we go. We have pandas right now, and it says you are not allowed to use pandas, and we didn't pass this test. So as you can see with this, we can very easily detect whether a student uses pandas. So that's example one. We're going to build it up from here. The second one is already a little bit more exciting, which is actually going to be checking if the student uses a for loop or not. And this is going to be in Java, not Python. So we're going to change the syntax up a little bit. And this is a very common example in Intro to Java courses, Introduction to Object-Oriented courses, things like that, where students need to learn the basics of a programming language or just programming concepts in general. And it's important that for specific problems, they use a for loop, and for specific problems, they use a while loop instead. And of course, you want to automate that so that you don't have to do it yourself and check this repetitive thing, but also so that the students will get notified about this before the deadline, see, hey, I'm using the wrong type of loop, and actually do still meet the learning objective of that assignment before the deadline. So they're learning. So that's great. In our case, for this one, we'll actually create two rules. One to check if there is a for loop, and one to check if there's no while loop used. Because students can be cheeky, and maybe what they'll do is they'll create a fake for loop somewhere just to meet the test. So let me switch back to the code again and go up here. So again, this one also I've set up right here, but let's recreate it in the example 2. And let's call this loops of YML. And again, our rules, and we'll start with one ID that is for loop. So here we're checking if they are using a for loop. This is the one that we want. So our match expected is going to be true. Then the pattern, and this is something that we have not discussed before, but in JAML, rhymes with camel, you can use one of these pipes if you want a multi-line pattern. So if you want a multi-line pattern as I need in this case, because the for loop needs to have content as well for it to be a valid parsable Java code, you can use a pipe. So I'll just copy and paste this over, just so I have less chance of typos. So in this case, very straightforward, of course. The Python, the Java syntax for a for loop uses brackets. Within those brackets, you'll define a for loop, but we don't really care about what's in those brackets. We also don't really care about what is below the for loop, as long as this is there's a for loop and it has contents. Again, with the ellipses, it can match anything, and it can match multiple lines as well. So let's add a message to this, simply saying you need to use a for loop problem, and then security is gonna be info, and then language is gonna be Java. Great. So that's number one. And then number two, I'll just copy over to make it all a little bit quicker for you. So actually what we're doing right here, we don't want a while loop, so I just call it no while loop. And in that case, of course, the match expected has to be false, since we don't want this while loop. The pattern, again, similar to the other one, the message is no while loop used. Great. So let's save this and go back to CodeGrade. There we go. I have an assignment set up for this. Right here, I already uploaded a file that does not use a for loop. Created a rubric category for this as well already, so we don't have to do it anymore. All we have to do is create our auto test. Let's upload the file that I just created. So that's this one. Yes, and let's add a level. At the category, select our rubric category, select unit test, Semgrep, and then of course again we select the fixture. So it was loop.yml, and again we select the whole student folder, as we're going to loop through all the files. So let's save this and see if that works out and what it does. Okay, so I already uploaded the file with the for loop. Yeah, so one more thing that I could mention right now that we're waiting anyways. I think that Chris mentioned using SQL before, and something he mentioned in the chat, and that is very true, is that there is this generic option as well. So instead of a language, you can also use the generic language. And with that, you can also try to pattern match within your SQL queries, making it even more flexible. Of course, it's all going to be, whoop, I think I made a little mistake. Haha, great. So let me see what went wrong here. Now, that is great, actually. I definitely prepared this to go exactly this way. So what we can do now is we can copy over our code, and we can go to the Semgrep. There we go. Let me just refresh this. Semgrep playground, which is very useful. We can run this, and we can add our patterns in here. So in this case, let me switch anyways. So let me change the language here to Java, and let's say for ... and see what is going wrong here. So I don't see what I did wrong. The demo virus.
I think you need an open curly brace.
No, because it is matching right here.
Okay.
Let me see if it has anything to do with the while loop. That's strange. Let's see if I copy the whole rule over and I remove this one. Something is strange here. I don't know.
At some point you named your file as loops and at some point for loop. I'm not sure which one you uploaded to CodeGrade.
Yeah. They should be identical, but maybe something else went wrong. Well, that's interesting. Let's just continue with the next example, I guess, and maybe I'll get back to this later on, maybe not, depending on the time that we have. I did check it before and it all worked, so probably I just made a small typo somewhere, which is on me. But the pattern that I shared actually does work, so that is interesting. Yeah. All right. No idea. All right, great. Let's head on to the next example. Is actually luckily one of the first times that during one of these webinars something goes wrong, so that's good. In this case, we're going to be working with the Jupyter Notebook, which is slightly different, and I'll show you how you do that. In this case, I want to share also the reason why I added this example here, which is because in many assignments for your test to work, you need the students to use specific naming. For instance, you want them to use specific function names for your unit tests or your IO test to work. But also if you want to do things like monkey patching or you're working with random variables, you need them to use specific variable names as well, so you can access them. What is nice with Semgrep is that you can already parse if they use the correct naming before the deadline, and you can proactively give your students a helpful message when they forgot to use these names or they made a typo, so they can fix it before the deadline, which is great because there will be less inconvenience for you and your students. So in this case, we have a Jupyter Notebook file that we have set up right here. So let me just quickly show you. And in this Jupyter Notebook file, I expect two things. I am using this bestsellers, and let me quickly make this a little bit bigger for you. So I'm using this bestsellers variable that I want to use and for my auto test, and I'm using this calculate weight function. Both of them I want to use in my auto test. So let's set up the auto test for the Semgrep for that and see how it goes this time. All right, so for this I have set up this file here, and we have two rules. Did I type in rules here, both of them? Yeah, no idea what went wrong. All right, I have to move on. So in this case I want two rules, one that checks the function name. This is expected true. And the pattern for this will be also on multiple lines, actually. So I want to check if that's not how it works. If the students defined a function that is called, and let me check it here, calculate weight. And I don't care what the parameters are for that. Just want them to use that function. And then I don't care what is inside that function either. So that's my pattern for this one. And let me continue with the security or the message first. The message is wait. With the info, and finally the language is going to be Python. Right. So let's have another rule, and I'll just copy and paste this one over right here. We use that. So the ID, of course, is going to be variable name. Match expected is going to be true. In this case, it's not a multi-line pattern. All we want to check if they actually use the variable called bestsellers. So we can do best sellers. We want them to assign it as well. So we can just use a meta variable here. Best sellers is something, but it has to be something because a meta variable cannot be nothing. So the message in this case is going to be the name. Security info again, language is Python. All right. So again, I have set up this assignment inside CodeGrade already. And I really hope that I didn't make any mistakes now. Great. Let's get the auto test here. Let's upload this file. Let me just drag and drop it from here. There we go. And since we're using a Jupyter notebook for this one, we actually have to have one step before our unit test, which is a run program step, which is to translate or convert our Jupyter notebook to a regular Python script. So how we're going to do that, we're going to look up the line that we need, just CodeGrade Jupyter notebook. And in our previous blog, we have the line for that, which is Jupyter MB convert to script. So we're going to use that. In this case, the file is called Amazon best sellers and convert to Python. There you go. Let me quickly check what the file name exactly is. Oh, lowercase. All right. Yeah. Lowercase or underscore bestsellers. Oh. Great. So we're converting it here, and then right here in our unit test, what we'll do is we'll select Semgrep again. Variable and then we'll select our test fixtures dot what was it called? Naming YML. And in this case, we want all the files that end with the Python extension. Let me just say anything.py. So in this case, we'll look in any file that is a Python file. Great. So let's try this out and see if it works. And I'm getting more nervous since last time. But let's give it a try. So of course, we will be publishing a blog about this webinar next week. And in that blog, I'll also be sharing the configuration files that do work. So probably I made a typo somewhere. I'm going to fix that. Time-wise, not within this webinar, but the typos I'll fix and I'll upload the actual YML files or YAML files that will work for you, so you can use them and start from there. So fingers crossed that I didn't make any typos right here. Good. All right, great. So step one is converting to a Jupyter notebook, and then step two is checking if the function and the variable name are correct. Let me show you one more time here what happens if I hand in the wrong file, and I have that prepared right here. So this is a function, this is a file that, as we can see right here, has a name bestseller, so not bestsellers, and the function is called calcWeight instead of calculate weight. And because of these changes, of course, our unit test step will not be able to find this calcWeight, the calculation weight function, and our monkey patching that we want to do, or maybe we use an IO test to parse different variables and check if the content is correct, cannot find bestsellers variable. So as you can see right here, converting worked, but our Semgrep did not work as it didn't find a match. Expect to find a match, but not found for both of them. So this is a very useful application with Semgrep as well to proactively make sure that your students are using the right variables and function names. So to summarize, Semgrep is built into CodeGrade, allows you to check for patterns, either wished for or prohibited, because we added this match expected flag or field. Configuration files are simple YAML files that, as you could have seen in this webinar, are easy to create and edit, and also to make a typo in. Finally, what I hope with this webinar is that you can get creative with it. Since I've known about Semgrep, I've used it in almost all the assignments that I set up, because especially in the more introductory ones, there's almost always something that you can use Semgrep for to make the student's life or the teacher's life easier and nicer. So hopefully with all the information that you got right here and the documentation on semgrep.dev, you'll be able to make your own crazy Semgrep creations. And if you have any cool ones, of course, you're always more than welcome to share them with us through support@codegrade.com or in our Discord. I'd love to see what you come up with and what you use Semgrep for, because I think there's way more possible with this than I mentioned in this webinar. Great. So thanks everyone for attending, and thank you for watching this on YouTube. Sorry for the small typo that I made, but if you go to codegrade.com and go to our blog, you'll be able to find the working Semgrep configuration file right there. All right.